So one really fun thing, and it relates to coordinates, which is kind of amusing since I just told you we're going to try to avoid coordinates, is something called a dot product. If V1 is x1, x2, and V2 is let's call it x1, y1, x2, y2. You might think that you could multiply these together to get a new vector x1, x2, x1 times x2 comma y1 times y2, but that doesn't really make any sense. But it turns out that a number x1 times x2 plus y1 times y2 is a number that does make sense relating to vectors. So this is an operation called the dot product, which takes two vectors and turns them into a number. And this has an incredible property, this number. And it comes from the law of cosines. And so when we study vectors more carefully, we'll prove this fact. But now I'm just going to tell you about it. That this operation, v1 dot v2, is, ready for this?
All right.
Magnitude of v1, the length of v1, times the length of v2, times cosine of the angle between them.
Okay.
So this comes from the law of cosines, and actually the picture we just drew previously about that negative, or that v2 minus v1 vector. But this dot product allows you to answer questions about vectors and angles, and that seem like they're very difficult questions, and it allows you to answer them super easy, in an easy way. So, just for fun, let's take two vectors. Well, let's start with two vectors where you do know the angle between them. 1, 1, and 1, 0. What's the angle between these two vectors?
This should be in radians.
It can be in degrees or radians, whatever you like.
Pi over 4.
Pi over 4. And how did you know that?
Because it's a 45, 45, 90 triangle.
Okay, so let's look at their dot product. If this is V1 and this is V2. So what is V1 dot V2? What is that?
So it's length of V1 is square root of 2.
No, sorry, not using the length. What is the actual dot product formula? The product of the x's and the product of the y's.
The length of, it's going to be 1 times 1 plus 1 times 0, so it's 1.
1. So the dot product is 1. 1 times 1 is 1 times 0. This is also equal to the magnitude of V1. So how long is V1?
Square root of 2.
Square root of 2. Length of this?
1.
Times cosine of the angle in between them. So that cosine theta is 1 over root 2. And what's cosine of pi over 4?
That's root 2 over 2.
Okay. Is that where we go?
Yeah.
Alright, cool. But now a more difficult problem that you wouldn't immediately know the answer to. Give me two random vectors in the first quadrant.
Just draw them, or?
Just give me coordinates.
Alright, how about we do 3, 5.
3, 5.
And 1, 4.
1, 1, 4. So here's our angle. Okay. And you don't know what this angle is.
Could probably find it, but
How would you find it?
well, we could say. So we could just say that we know cosine. So I'll call this angle theta here.
Mm-hmm.
So cosine of theta, or I guess actually tangents would be easier to work with.
Okay.
So tangent theta is 5/3,
Uh-huh.
and then tangent. Then you can figure what theta is from there if you had a calculator.
Right.
And then you know tangent of this angle of this triangle
Uh-huh.
is 4.
Yep.
And then you just use a calculator to figure out what this part is.
Oh, cool. Yeah, okay, so smart. That's great. But now we can do it in a very direct way. V1 and V2. So what is the dot product of these? V1 dot V2?
So it's 3 plus 20, so 23.
And the dot product is 23. The magnitude of V1 is
So root 17.
magnitude of V2.
Root 34.
That's a lucky break.
Mm-hmm.
All right, so we have 23 equals root 17 times root 34 times cosine of the angle between them.
Mm-hmm.
What's root 17 times root 34?
17 root 2.
Okay. So cosine theta is 23 over 17 root 2. Just from, sort of instantaneous arithmetic. So now you can solve problems about angles between vectors using the dot product in almost a miraculous way. So that's one really interesting thing about vectors. And actually, when I remember learning linear algebra, I thought this was amazing. So anyway, so we'll start on this not this week, but next week, and I think we're gonna have fun.
Okay.
All right, good job, man.